In this section, we're going to have a look at the scalar product, which is also known as the dot product. And what that enables us to do is to calculate an angle between two vectors. So if here we had vector A and vector B, we would be able to calculate angle theta. So let's have a look at how we can do that. The scalar product then is found by taking the first component of two vectors. So here if we have vector A, which is a1i plus a2j, and vector B, which is b1i plus b2j, we take the I components and multiply them together, so a1 and b1 here, and multiply them together, and add them to the product of the j components, so a2 here and b2 here. And if we do that, we find the scalar product or the dot product. Similarly, if we were going to work in 3 dimensions, then we would also add on the k components. So here, the product of the k components. So here, a3 multiplied by b3. So that would enable us to find the dot product. And once we've got the dot product, we are going to also use another formula. So we can derive by finding the resultant and using the cosine law here, if we wanted to, that the dot product, or the scalar product, is also equal to the modulus of A, or the magnitude of vector A, multiplied by the modulus of vector B, multiplied by cos theta, which means that we can rearrange this formula. So in order to find theta, we would find the dot product using this formula here, and then divide by the modulus of A multiplied by the modulus of B. So for this question, you've got two vectors, vector A and B. I just want you here just to find the dot product. And then in this one, again, you've been given two vectors, but here you've been asked to find the angle between them. So just have a think about the two formulas we've looked at on the previous slide, and then try and apply those to these questions. So in the first question then, all we need to do is find, so the notation here means find the dot product. And we looked at earlier that the dot product is taken by looking at the product of the I component, so here 1 multiplied by 2, and adding the product of the j component and adding the product of the k component. So the dot product here would be 6. That's fairly straightforward. For this one then, we need to go beyond that and actually find the angle. So we need to use this formula here. The dot product is equal to the modulus of A multiplied by the modulus of B multiplied by cos theta. So the first thing we're going to do is actually find the dot product. So the dot product, again, take the product of the components, the coefficients of I, and add that to the product of the coefficients of j, and we get 63. Now we need to look at the modulus. So remember, this is the magnitude of vector A, so we're going to find that using Pythagoras. So we use Pythagoras here to look at 3 squared plus 4 squared is going to be 25. Root 25 is going to give us 5, so that's where these come from. So now we know that the dot product, which we found here, is equal to modulus of A multiplied by the modulus of B multiplied by cos theta, so we can rearrange that in order to give us cos theta, and then find the inverse of that to give us theta, which is going to equal 14.25. So there are some special properties of the scalar product that can be useful for us. First of all, looking at in terms of perpendicular vectors. So we know that the dot product equals the modulus of vector A multiplied by the modulus of vector B multiplied by cos theta. Now, if the two vectors are perpendicular, the angle between them will be 90, and hence the cosine of 90 will be 0. So the dot product will be 0. So if we have two vectors where the dot product is 0, we can ascertain the fact that those two vectors must be perpendicular. So two vectors are perpendicular if and only if the scalar product or the dot product is 0, as we said there. If they're parallel, the opposite is going to happen. We are going to ascertain that the angle between them, or cos theta, would be 0, and we know that the cosine of 0 is 1. Therefore, when we have parallel vectors, we know that the dot product will just be the product of the magnitudes, and that's what we're saying here. Coincident vectors, so that's vectors that lie on top of each other. For that, we know that if if we were finding the dot product, it would be the magnitude of A multiplied by the magnitude of A, because it's the same vector, multiplied by cos 0 because there's no angle between them. So in the special case where we have a coincident vector, we can say that the dot product will be A squared.